Hi girls, this is Miss White, and we are going to finish our Permutations Notes via Doceri. At any point throughout the video you can pause or replay if you do not understand or you need extra clarification with what I am talking about. Alright, let's get started. On our first slide here I have the formula for permutations. N stands for the total number of items you have in your set. P stands for permutations. And R is the number of items you are selecting out of your full set. It is equal to n factorial over n minus r factorial. Factorial was explained to you as, for example, you would have 4 factorial. You would figure that out by doing 4 times 3 times 2 times 1 without skipping any numbers all the way down to 1. Multiply them all up. You would get 24. Okay? We're going to have to do that several times throughout this video. Our next formula we have is for distinguishable permutations. It is used when you have repeated items in a specific set. We are going to use this when we do example number 5, which has repeated letters in the words even and California. And you want to figure out, even with those repeated letters, how many different permutations can you decipher. So n is still the full number of items in your set. And then on the bottom here you have things called S sub 1, S sub 2, all the way out to S sub k. In the problem that we do, all of these S sub 1s and sub 2s are going to stand for the different letters that are repeated. And you're going to fill in a number for S sub 1 for the amount of times a certain number is repeated. And each of those S's stands for a different letter. Let's try our first example together. It says 8 teams are competing in a baseball playoff. In how many different ways can the baseball teams finish the competition? Our solution says there are 8 factorial different ways that a team can finish. So let's write out what 8 factorial is. We are going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You can either use the factorial option in your calculator by going to the Math button, scrolling over to your probability menu and down to your, I forget what option it is, but it is the exclamation point. Either way, whether you just type the numbers in your calculator or use the factorial option, you will get 40,320 different ways. For part B, it says, oh, I'm sorry, I didn't read the question. For question B, it says, in how many different ways can 3 of the baseball teams finish first, second, and third? So you are only concerned with the first 3 places. You want to know how many different ways can 8 teams finish in first, second, and third. So any of the 8 teams can finish in first place. After you select the first place winner, you only have 7 teams remaining. So 7 teams only have the opportunity to finish in second place. After you have selected first and second, you only have 6 teams remaining that could finish third. So since we are working with permutations, we need to multiply those 3 numbers together. 8 times 7 times 6. When you do the multiplication, it would be 300 36. You could also figure this out by doing 8p3 on your calculator. Those are equivalent, these two things right here. Okay? In example number 4, the question they ask you is, you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. And how many different orders can you complete 4 of the assignments? So of the 6 assignments total, you want to choose 4 assignments. How many different ways can you choose 4 assignments from the 6? They give you a hint in the solution that says find the number of permutations of 6 objects taken 4 at a time. In other words, you want to calculate 6p4. If we go back to our permutations formula, we know that we are calculating 6p4. So in this case, 6 is equal to n, 4 is equal to r. So when I plug in here, I will have 6 factorial over 6 minus 4 factorial. Let's just simplify here. On the top I still have 6, but 6 minus 4 on the bottom will leave you with 2. 6 factorial we know is 6 times 5 times 4 times 3 times 2 times 1, or 720. And on my bottom here I just have 2 factorial, or 2 times 1, which is 2. When I do the division, I get 360 different ways that you could choose 4 items from 6. So let's fill in my last blank here on the bottom. It says you can complete the 4 assignments in 360 different orders. My last example, example number 5, is a problem where we will have to use our distinguishable permutations formula. It says find the number of distinguishable permutations of letters in the word even and California. Let's go back to our formula here. N factorial over s sub 1 factorial times s sub 2 factorial all the way out to s sub k factorial. N stands for the total amount of letters in each one of our words, either even or California. All of my s sub 1s and s sub 2s, they stand for an individual letter that is repeated. The number that you are going to fill in there is how many different times it is repeated throughout the word. So, let's fill in the blanks here. I know that the word even has 4 letters, of which the letter E is repeated 2 different times. I have 2 E's in the word even. Okay? So my number of distinguishable permutations, I'm going to start out with the top here. Since I have 4 letters, my n factorial on the top is going to be 4 factorial. On the bottom, I want to focus on the repeated letters. I have 1 repeated letter, so I will only have 1 factorial, or 1 thing that's factorialed on the bottom. And the E is repeated twice, so I plug a 2 in for the bottom. When I simplify, I know that 4 factorial is 24. I know that 2 factorial is 2. For a final answer of 12 different ways for distinguishable permutations. Okay. That means, just for a quick example here, if you are spelling the word even, since you have two different E's, and I put one in uppercase and one lowercase, when you switch the E's, they're still spelled the same way. The only way you can distinguish between these is because I put one in uppercase and one in lowercase, but otherwise they look identical. So that would not be a distinguishable permutation. So even the two E's kind of mess you up here, and that's why you have to use a different formula. Alright, let's focus on the word California. California is a little bit more complicated. If I look, I have two A's that are repeated. I have one I and another I over here that is repeated. Those are my two repeated letters. The whole word, though, has 10 letters, of which my two letters that are repeated are A and I. They are each repeated twice. So now, here's my fraction bar. I have my total number of letters in California is still 10, so I will have 10 factorial on the top. The bottom of my fraction will look a little bit different since I have two letters that are each repeated twice. So since I have two letters that are repeated, I'm going to have two things that are factorialed on the bottom. Since they are each repeated twice, that would represent my A factorial. Another 2 factorial would represent my I factorial, or my I that's repeated twice. Okay? When I simplify, on the bottom, I will have 4. On the top, I will have 3,628,000. And this is definitely one I would use the calculator for. 800. Final simplification, I need to do my division. When I divide, I have 907,200. Okay. If I wanted to give you an example here of a distinguishable permutation for California, again, I could switch the A's here and put the capital A where the lowercase a is and the lowercase a where the capital A is. I could switch places, but other than them one being uppercase and one of them being lowercase, you would not be able to tell the difference. So that would be an example of something that's a permutation, but not a distinguishable permutation. Okay? For the remaining time in class, I want you guys to work in partners. Yes, Erin and Natasha, I want you working in partners. On 12.3, the standardized test practice, whatever you do not finish in class does become your homework. Okay? Good luck on your PSATs tomorrow. You guys will do fabulous, and bring questions to class on Thursday if you have any. Good luck. Bye-bye.